Hello and welcome to this SOFiSTiK tutorial. In this video I will show you how to use Revit families for the Superstructure command and talk about the basics required to do it in an efficient way. What is a superstructure? A superstructure is a volumetric geometry that follows the axis alignment of the SOFiSTiK Bridge project. It is based on a 2D section which is placed in an interval to achieve perfect accuracy for the parametrized superstructure volume that is created. It is based on a metric generic model adaptive family. It has one adaptive reference point and it can consider both variables as well as secondary axes for its parametrization along the axis alignment. When we talk about superstructure families, we talk about two-dimensional families in the plane from left to right. So this vertical plane, and you can see in the view cube the alignment of the plane in which the reference has to be created. When we now take this family and place it via the superstructure command, the way you have to imagine it is that we reference this adaptive point exactly to the origin of the inserted axis. The way you can imagine it is that the two-dimensional reference is placed in an interval along the axis, which is then swept along the alignment of the axis. Let's talk about special cases. For example, the first thing that I started with was to create multiple boundaries, to create multiple volumetric geometries within a single family to create it along the axis alignment. Using the superstructure command, you would expect the program to simply place the two boundaries along the axis alignment to create this volume, but the superstructure command does not allow you to have multiple boundaries within one family to create the volume, meaning that only one boundary, as you see it here, is viable. On the other hand, what you can do is have multiple boundaries within one family assigned to a specific family type. Here is the family types interface, and I created a type name left as well as a parameter left. There is a second type right as well as a parameter right assigned, and I choose this left parameter as a type parameter of data type yes and no. Meaning that for every type, this parameter is either on or off. This allows me to assign this yes or no to the visibility of the boundary. Meaning that for this family type, the left boundary will be set to visible, and as the right boundary now gets the right parameter assigned, it is set to invisible. Within the project, you can now select the superstructure, and here you can see that when I select the left subtype of my family number 1 here, that the right boundary is literally invisible. Meaning that when I want to place the left boundary for this parapet, for example, I select left, I start the superstructure command again, select my family 1 once more, and select the right type. Then the left side will be invisible, and I can simply create the volume. Let's quickly talk about openings. I talked about that a single boundary creates the volume of our structure. But what happens if you create boundaries within boundaries? Here you can see a simple rectangle which is created in my project to the right. If I now create a second rectangular boundary within my rectangular boundary, you can see that once the family is updated, the SOFiSTiK Bridge and Infrastructure Modeler will also update the volumetric geometry in your project with this opening in mind. A little side note here is that you are neither restricted by the amount of openings nor their geometry. A special case of these openings are circular openings, because they have to be modeled as two half circles in your family. Let's create a superstructure family. To start, create a new family based on a metric generic model adaptive template. In the family editor, I will now create a new point element, place it on this plane and align it to the middle of my family. Next, I will select the point and make it adaptive. Superstructure families are two-dimensional families placed in the reference plane left to right of the adaptive point, meaning that as the next step, I will select the work plane which is vertical of this adaptive point. Everything else required is to simply create a boundary. You can use any of these commands here to create the boundary, but I will simply start with a rectangle. By activating 3D snapping, you could either create just the boundary lines, or with 3D snapping activated, you can also create the corresponding reference points that define the geometry. These can be freely parametrized. Next up, I want to assign a family type. For example, this will be my left aligned family part. So I will call the type of this family in family types left. The already existing parameters don't really matter for us for now. I click on OK, and as the next step, I want to save this family. Why do I want to save this family? Because here I can give it a specific name. And this will be my parapet. And I will save it on my desktop. Why will I call it parapet? Because I will modify the shape of my rectangle to represent a parapet's assignment. To modify the existing points, you can dissolve the selected boundary lines. This way the points will not be deleted. I will now select the first point, and you can see that the arrows indicate in which plane we are modifying the point. And keep in mind, all of them have to stay in the same plane for them to be assigned properly. I also select my second point, but this one I will move a little bit to the left. And based on this point, I will now create a vertical offset. So I select the horizontal plane of this point. And just a quick reminder, by creating a new point element directly in its alignment, I now have a new point which I can assign a negative offset of, let's say, 200 to it. A second point, which should be perfectly aligned to this bottom one, should be created. Click on OK. And I can move it up for the references to be assigned. Keep in mind, this point here is now based on this first assigned point, meaning if I move it, the other point will move with it. I will now quickly just modify this a little bit for it to represent it. And what I want to do next is, based on these reference points, I want to create a new boundary. I select 2 points and click on Spline through points. This will automatically assign a line to these 2 points. I do this for all the points I created. And now if I change the alignment of, or the geometry of my reference points, they can now change the assigned splines with them. This is all that is necessary in the family. So now I will create a new project. Select the standard construction template of Revit, go to the 3D view, and in here I now want to create a new alignment via SOFiSTiK Bridge. In here I click on Axis, create a new one, and I will leave the standard settings. You can immediately see the new generic model, which is created as the reference of the axis. And what I want to do next is I want to load this family into my project. Once I load it in here, it suggests the reference point as well as the boundary. This is now a superstructure family that will be available as soon as I click on Create in the Superstructure tab. You can see in the drop down of Profile Family that the parapet family with the type left is available, and no additional parameters will be assigned yet. I click on OK, and the program will immediately create the volumetric reference of this parapet along the axis alignment. With a double click onto the volume, we can take a look under the hood of the SOFiSTiK Bridge Infrastructure Modeler, and in here you can see, based on the alignment's geometry, an interval of these families will be created that will be swept along. This guarantees you a perfectly accurate alignment of the volumetric geometry. With another double click onto the family, we can modify it, and in here I now want to create a second boundary. I will once more select the reference plane of my adaptive point, and I will create another rectangle to the right. If we were to load this family into the project now, you would get an error from the SOFiSTiK Bridge and Infrastructure Modeler because two boundaries are not allowed to be created with this command. To have both of these boundaries assignable in the Superstructure command, I now once more go to Family Types, and I create a second type of type right. Additionally, I want to create two more parameters. You can create them down here, and I want one with the name right, a type parameter of the type yes or no. Click on OK. I can also duplicate this parameter, which I will call left. These type parameters can be activated and deactivated by clicking it in here, and I want right to be assigned with the type right, and I want the left one to be activated in left. These will be changed according to which type is selected. Click on OK, and by now selecting the boundary of the right element, while I have left assigned, doesn't really matter, I want it to be visible based on this parameter. By clicking onto this small rectangle next to the visibility setting, I can assign right to this boundary. You can see that it's now transparent while the left type is selected. I select the left element and I assign the left parameter to it. I can now change to the right type, and you can see that the assignment swapped. I will now load this into my project once more, and I will override the existing version and its parameters. I can close the family, and what I can do now is go to SOFiSTiK Bridge, Superstructure, and create another volumetric element based on this type. And when I scroll down, you can see here is parapet, which now has two types assigned. When I select left, you can see that only the left side is active. If I select right, the right side is active. So I create a second superstructure this way, where only the right side of my parapet is assigned. This way you can use one family to create multiple superstructures. By going to SOFiSTiK Bridge user interface and activating the infra browser, you can access the axis that we created as well as the superstructures that we created. I will right click onto one of them and edit the profile family type. This way you don't need to select the volume and select the subfamily. And in here you can now even add additional boundaries within the already existing boundaries. One way to create an opening is to simply select a new boundary and place it within the already existing boundary. Keep in mind to also assign the visibility settings to it. So this one should be active when right is active. With the left parapet, I want to assign a circular opening. Keep in mind that circular openings need to be created as two half circles. I first create a reference point and I create two center arcs on it to represent my circular opening. And I select it to assign the visibility setting of left to it. simply by loading into the project once more, you can now go to the already existing components and tell the program to refresh them. So I select the first boundary and click on refresh. The program does not require you to access the superstructure command once more, but it will create the volume accordingly. Click on refresh for the second one. And we can take a look at our openings in the geometry.